Now we consider a special type of series known as p-series, which are easy to recognize and can often be used with other types of series. A p-series is an infinite series of the form sum from n equals 1 to infinity of 1 over n to the p, where p is any real number. The variable doesn't have to be n. The important thing is that whatever the index variable of the sum is, that variable is being raised to the p power. If we recognize that we have a p-series, it's easy to determine convergence. If p is greater than 1, the series converges. If p is less than or equal to 1, the series diverges. For instance, does the infinite sum from n equals 1 to infinity of 1 over square root of n converge or diverge? We recognize this as a p-series with p equals 1/2. Since 1/2 is less than 1, this series diverges. Does the infinite sum from n equals 1 to infinity of 1 over n to the 5th converge or diverge? We recognize this as a p-series with p equals 5. Since 5 is greater than 1, this series converges. Does the infinite sum from n equals 1 to infinity of 1 over n to the 18th power converge or diverge? Well, this is a p-series with p equals 18, and 18 is greater than 1. So the series converges. Another example. Consider the infinite sum from n equals 1 to infinity of n cubed plus n squared all over n to the 5th. Does this series converge or diverge? This isn't a p-series, however we can use algebra to rewrite this as the infinite sum of n cubed over n to the 5th plus n squared over n to the 5th. We're allowed to then split the sum so we have the infinite sum of 1 over n squared plus the infinite sum of 1 over n cubed. Each of this is a p-series with p greater than 1, so both of these series converge. The sum of two convergent series is convergent. This means our original series converges. Another example. The sum of k equals 5 to infinity of 1 over k raised to the pi, does this converge or diverge? First, notice that the fact that we're using k instead of n makes no difference here. Also, the fact that we're starting at k equals 5 doesn't change whether the series converges or diverges. So we can still look at this as a p-series with p equals pi. Since pi is greater than 1, this series converges. Finally, we can look at another problem, looking at the sum from k equals 1 to infinity of 1 over quantity k plus 5 squared, does this sum converge or diverge? We can introduce a new variable t, which we set equal to k plus 5. When k is equal to 1, t is equal to 6. When k is equal to infinity, t is equal to infinity. Substituting in, this gives the infinite sum from t equals 6 to infinity of 1 over t squared. This is easy to recognize as a p-series with p equals 2, so this series converges.